So linear approximations are basically used when we're looking at changes in an overall function, primarily when there is a very small change in the input or the x value. So some notation here. The change in f, the change in the function, can be defined as the difference between two evaluated points. The evaluated point of the initial condition and with the little tiny change in x. So for instance, in an example that we're going to look at is looking at maybe like the fourth root of 16 in comparison to the fourth root of 16.1 or 0.2 or something like that. So the change would then be the decimal addition that we've been added onto our original amount that we're inputting. For linear approximations, it basically uses a derivative to estimate the change in the function. So the derivative is defined to be this, and if the change is so small, we can actually approximate it by saying that the change in the function f is approximately divided by the change in the x value, which is equal approximately to the derivative at that point a. So if we isolate for the change in f, we multiply both sides by the change in x. So let's take a look at this example. So how much larger is, say, the fourth root of 16.1 over the fourth root of 16, which is, we know it to be 2. So ultimately we're looking at what is the difference between 16.1 minus the fourth root of 16, which we happen to know is 2. So a couple of things we need to identify. Overarching function that we're looking at is the fourth root of something. Or you can write it as x to the fourth, or 1/4. So we also need to know what our a value is, what we're plugging into this. In this particular case, our a is 16 and our change in x is 0.1. So now we can write that the change in our function is approximately the same as the derivative at a multiplied by our change in our x. So we do need to find the derivative. So f of x right now is x to the 1/4, and therefore the derivative is 1/4 x, and you subtract 1, so it'll be negative 3/4. Our change in our f then is an approximately 1/4 x to the negative 3/4 times by our change in our x. Actually, hold on 1 second. We have to plug in our a, which is 16, and we have to times it by 0.1. So now, change in our f, approximately 1/4, fourth root of 16 to the power of negative 3 times by 0.1, so approximately 1/4 times 1 over fourth root of 16 is 2 to the 3 times by 0.1, so approximately 1/4 times 1 over 8 times 1 over 10. So then we get that our change in f is approximately, and if you plug in your calculator, you get 0.03125. Now if we actually did have our calculator with us and we actually said what is the difference, and we said the fourth root of 16.1 and I subtract the fourth root of 16, you actually will get 0.00311777024 etc. So this approximation is actually quite accurate.